Hello everyone, this is Yash Kumar and this is the part 2 of my PyCaret tutorial. And in this video, we'll be going through how we can use PyCaret to solve clustering, anomaly detection, and association mining problems. So again, let's just jump straight into it. So first one is clustering. And as you can see, we just perform the regular steps. By the way, just as a suggestion, maybe it might be better to go through part one before in case you have not uh, seen it, because I might skip certain things assuming that people might have watched part one instead of explaining it more line by line, you could say. And yeah, so with this one, I chose the Pokemon data set since I'm a huge fan. And yeah, I mean, there's not really more of a reason behind that. Looking at the data set, I saw some columns which weren't quite useful, I think, in terms of clustering and might have a more negative impact, perhaps. So I removed the name, type 1, type 2, and number from it. And now that we have a data set ready, again, from PyCaret or clustering this time, we're calling a clustering experiment for a more object-oriented way to do these things. And we're just setting up, as I previously mentioned, we just set up the data with all different types of cleaning and other steps that it handles internally. And since I'm not as experienced with clustering, I just took a look at all the different models that are available by just calling the models method. And as you can see, there's some that I might have heard, k-means, dbscan, and so on. So I just used the first one that I knew of, which is k-means clustering. I just called create model k-means, which, because of the object-oriented way in KM now is a model which performs k-means on a provided data set. And then I'm just assigning clusters using k-means, I mean, assign model and providing a model which basically assigns each row a cluster. So as you can see now, from what we have previously till legendary, now we have another column which is cluster, which has assigned like each Pokemon an individual cluster. And then I'm just plotting it using plot model method, and the plot type is cluster. So as we can see, there's like it has performed some principal component analysis to create a 2D cluster plot. And it's interesting to see there are like four clusters. Yeah, I mean, uh, now that we have prediction as well, we can just call predict model and provide it the model and the data set. And as you can see, it has like now the same information, like what cluster does each Pokemon belong to, and maybe that's something we could explore. Um, I'd just like to point out like 0 and 4, which happens to be the two starters, happen to be in the same cluster. So maybe it is clustering based on the statistics that we have provided. Uh, and yeah, I mean, like just save models, and we have this pipeline, which all it does is it does some steps before using transformer wrapper, and then finally uses k-means to classify it. So that was clustering. And then next is anomaly detection, which again, I'm using the anomaly dataset, but since that is the only one that PyCaret provides, so I didn't have the alternative to try a different one from their tutorials. But we have this anomaly experiment. We set up the data set again, similar to previously. We have all these different models, and I actually did not know anything about anomaly detection previously, so I had to look up. And the closest one that I've heard of is K nearest neighbors detector, I guess, since that is similar to clustering, I think. And yeah, so I just called create model with KNN, and uh, again, we just assigned the anomalies using assign model. Again, this is quite similar to clustering, hence why I grouped them together in this video. And it's assigning an anomaly score, which is how likely I think it is an anomaly is what it's calculating. So you can see like the ones which have lower values tend to not be an anomaly, while those which are quite on the higher end, like around zero point 0.7 and zero point 0.8, are being treated as an anomaly. and for some reason I think this didn't come up, but it basically creates a 3D graph, uh, which a 3D visualization, which is a good way to, you know, see the anomalies in action. Since it is a 3D visualization, yeah, it might take some. But yeah, okay. So now that it's ready, you can see like some of these yellow ones, the yellow dots are the anomalies, and you can see that they're not as close with the rest of them. But there are some that are definitely sneaking through, which could have been perhaps not an anomaly. But yeah, I mean, it is a classifier, as you can see, some of uh, anomaly detection that you can use. And PyCaret again makes it so much easier to do these things because you personally you just do not have the ability to train them on all these different models and pick the best one. And if you just call like evaluate model, I think it's able to just go through all of these different models and yeah, just pick which one it has the best. I don't think it's evaluate models. Maybe I'll just quickly confirm. I think it's a different method. Um, you can again check with my binary classification and the other videos. Yeah, compare models. Apologies. Yeah. So I meant compare models. So if you just perform compare models, it will run it over all these different models and see how it performs and choose the best model for you. But in this case, I just decided to go with k nearest neighbors. And again, we just have predictions with these anomaly scores. And as I previously mentioned, we're just saving this pipeline to be able to be used later on. And now association mining. So this is actually quite a unique one for us because instead of getting the latest PyCaret version, we actually took like the older version and we're downgrading pandas as well. And the reason for that being that unfortunately association mining has been removed in the later versions of PyCaret, and that does mean we can't use it anymore. But since I did want to explore this, since it did used to exist at some point, and yeah, I mean, it had two data sets available, France and Germany, which I think is a list of items that are there. And what we're doing is like, so this is the alternative to the object-oriented way where we're just calling setup directly instead of assigning it a inside a variable. But now we need to provide the data every time. So now we have S equal to setup of data set, the transaction ID and item ID we provide, which is invoice number and description. And based on that data, we're now able to create a model. And by getting it said, we can see like a lot of these items are usually bought with postage, but I don't think that's exactly what we need in our scenario. So we're going to use an extra particular, what do you call it, the field, which is called ignore, not field, but another argument for setup, which is ignore item, so that it ignores postage and we are able to see the actual association between different items. So now that we do the same thing again, we can see like the woodland item is quite often bought with fruits and lunchbox. So that provides us some unique insight with respect to association mining. So yeah, I think that hopefully this is useful for you and you're able to use PyCaret. And I'll be back next time to talk about the time series forecasting that PyCaret provides.